Hey there guys, we are here with some more work on the pallet table. It's one of these things I spent all day, well not all day, but basically most of my day prepping the pallet stuff and to make the tables. And that especially had to happen, well it especially had to happen because it had to get happen, but my other excuse is that my printer was running for 20 hours and I did not have a chance during any part of the day to stream because of that too. So we are getting a quick stream in here right now. I right now got home and found packages from Amazon, so I'm going to open them up really quick, which is why you're staring at my desk. This would be the stuff for this guy right here. The other contest we're entering, which is the, extruder indicator that we made. RGB lighting extruder indicator. I didn't have any common cathode RGBs. I only had common anode with the exception of one random one that came from who knows where. So I bought myself a pack of those as mentioned, and if you hear me ripping stuff, that would be me opening up more of these Hall effect sensors that came in the other package. That would be all these guys. 49Es. Seem like they should work. And then, because I've never had to do this before, I didn't have any 8mm magnets, so now we got 8mm magnets to go with it. Again, that goes in this guy, so this guy will get the LEDs on these outer holes, and then on the inner holes, well, in the middle holes, technically speaking. It's hard for you to see because this is a black PCB. Actually, it looks like with the light, you probably can pick up a little bit of it. But the 3 holes in the center here, those would be the Hall effect sensor, and then those 2 holes right there are the resistor, current limiter resistor. I got to double check the Hall effect sensor to see if they also need resistors. I know that some Hall effects, these are analog, so I don't know. The digital ones I had, the digital Hall effect sensors, those ones needed a pull-up resistor. I don't know if these guys will, so we might have to add another space for a resistor here, and then there's the magnets mounted on the back of that. I went ahead and slapped that together last night because I had magnets. And again, in case you forgot, that's how that works. So as the extruder indicator, as the extruder is spinning and moving the indicator, it will rotate around, and each of the Hall effect sensors will govern RGB. So 3 Hall effect sensors, 3 RGBs. So that's an update on that project, since all that stuff just showed up, and I may as well tell you. So let's get back to Fusion. In case I did not mention this, actually I'm 100% sure I didn't mention this. This is going to be a quick stream, about an hour, because I'm trying to get back to put a second coat on the pallet stuff that I coated today. Well, I coated just now. I did all the prep work, all this sanding, nail removal, etc. Breakdown. I did the rest of that, some of that yesterday, the rest of it today, and then it was time for finish. And the finish, 2 hours later, put a second coat on, etc. So within 2 hours, I've got to be back there to throw the second coat on, because I don't feel like sanding it back down to put a second coat on. I could do that, but I want this stuff as done as soon as possible, which means that I want to be able to finish the back side of it that is not getting finished right now tomorrow at work. Tomorrow after work, well, technically speaking, I'm going to have to take a late lunch, put the first coat on, then 4 o'clock, clock out, put the second coat on, and then we just wait till Tuesday, and Tuesday I'll bring that stuff back to the house so that I can show you guys what I'm working with here. Otherwise, we got this digital representation of what I'm working with. Also, about 15 minutes before I end the stream, I'm going to go start a coffee on the stove. So, since we only have, like 45 minutes now at this point because of all my talking and not starting around time. Actually, I said that, but no, it is like 45 minutes. I really should not be pushing my time limit. Well, I mean, it's one of those things. The finish doesn't care if I'm 5 or 10 minutes late, but let's call it 45 minutes for right now. Regardless, let's go ahead and turn these on. Obviously, we had several things to where are you guys hiding? Reveal in browser, please. Find in browser. All right, there we go. Large slat. Select all. And we will go ahead and do this cool thing right here called a selection group, which I've never actually done on stream before. or selection set, whatever, because I've never had a need to. So you click it and go on. So the things that we needed to get done on this guy to get him finished, the only thing I mentioned last time was just creating this screw knob right here, which would tension, tighten up, tension the slats together. The other thing is I wanted to make the base version of the spacer, and then I want to figure out how I'm doing that too, just because the point of this specific design, again, the other designs would be more more convoluted, more intricate. The other designs would be more intricate. This guy's supposed to be no hardware. It's supposed to be just print and play. So for that reason, the spacers, I'm not entirely sure how I'm going to be putting them in here. And so that's two things. That's the screw and the spacers that I'm hoping to get done in this 45 minutes. And then the third thing is something that occurred to me this morning when I woke up, which is you may notice that this is not actually holding on to here. So we're going to fix that. And the way we're going to fix that actually is going to help us with the whole entire overhang. Well, it's going to help us with some of the overhang problem at any rate. Three things on that point to talk about. One, I was also thinking about it, and let me turn this guy off. Not that guy. Where's the other guy? I was thinking about it, and there's not particularly a reason to have a full cap here. So we may just do put a hole in that, and that will solve some of our overhang problems with this guy. And the second thing, the way that we're going to implement, I believe, the locking, keeping this guy in place, is I will actually take this wall out and build another bracket for this guy. So this guy will have a bracket that locks into this bracket. That's my current idea. So let us go ahead and I mean, these guys should be in the frame. I don't know why they did not end up in the frame. I understand why these guys didn't end up in the frame, because, oh, wait a second. Last time it told me that you couldn't move it. I guess because these guys are mirrored. I guess it's because these guys are mirrored. So if I try to move this guy, it's going to give me an error, right? Yeah, give me an error down here in the corner. Yep, okay. So because those guys are mirrored, even though, as we discussed last time, them being mirrored, they still get affected by everything else that happens. For example, all this changed to vertical. This stays the same. So even though they're linked in that way, I guess they can still be moved around. Which, again, is not a problem I normally run into because I don't normally do things this way. Regardless, let's get on to actually getting this built. So first thing is to decide how we want this locking in and what the shape wants to be. Now, this hole right up here is probably just going to end up getting moved to this guy, and this guy will just get tension against itself. That makes things a little bit easier for us because it gives us a different, we can change the way we're oriented on the printing part. The next thing to talk about is, right now we have this oriented up and down, so that's flat with this, everything's square. That is cool. That is fine. I kind of like that. But if we turn this sideways, that would make more sense for locking in. So if this guy was rotated 90 degrees up and down, then we would be in line with any lock-in mechanism that we put on here. Again, my idea being that we have basically a C-channel type deal going down into this bottom joint. So those are the ideas that we've got right now. Or the things I'm thinking about, I should say. So, let's take a quick breath, really quick, and try to slow myself down because now we've got everything out of the way and we still have, 40 minutes, let's say, for this to get done. So, we can chill out a little bit. We can move on to actually talking because all the prep work, all the I shouldn't call it meaningless, but all the necessary talking that does not exactly get us to where we're going is now over. So we slow down. All right. So first thing to do is I will go ahead and take this bracket, and let's see, which orientation are we? All right, we went from that way. And let's see where we're at on this one. Yeah, okay. So let us not there. This guy, right? Yeah, that guy. I'm gonna go ahead and get rid of that guy. Well, try to get rid of that guy. Try this again. Maybe if I flip over here, you'll let me. There we go. All right. So that gets rid of the back panel, and we can go ahead and start inserting in this guy. Yeah, that is going to break because we no longer have the hole there. That's the whole sketch and what you call it? And extrusion cut. So let us go ahead and we're gonna make a new component. Makes sense. Actually, rather than do that, let's roll all the way back here. Basically I'm looking for, before we do this mirroring, all the mirroring stuff, we'll go ahead and hop back here to do our bracket alignments. And we will hop into frame, create a new component, cross beam bracket. Yeah, it's one of these things, because I'm not sure with fusion design stuff, you know, what proper I'm gonna call it code styling is. So for example, in Python you'd normally do snake case. In JavaScript it's camel case, etc, etc, etc. So I don't know what's expected here, so you'll see me mix up like small space slats, cross, you know, no space beams. I'll do silly stuff like that just because I don't actually know what's expected here. And the question is, does it really matter? Which very well may not be the case. Where are you at in here? Okay, that is you. Good. That is you. You do not have any planes on you. Control Z because I just moved you. So, did I put the planes on the other guys or no? I did not. So, we are going to just put the plane inside of here and start drawing. So, with the way this guy is going to be printed, it does look like it's still going to be printed vertically like this, because we still have this tab here. We can't flip it upside down with that tab still here. Now, if we get rid of that tab at some point, that may change things. But the point that I'm getting to here is, if I want this to lock into that bottom one, then more or less we're just going to go ahead and put a tab down the center here is my idea. Seems to make sense to me. And we'll just use that to slide into place. And we'll want to project, well, we want to project this. Actually, let's not do that just yet. I'm not going to build that just yet. I'm going to go ahead and do the wall thickness here. Wall thickness. And we'll extrude this first. And because I want to go ahead and reposition everything, because obviously if this is solid down here on this side like the other one is, then we're going to want to lift this whole entire group up, this whole entire assembly up. So let's get that done. Sketch. And I can't recall if we did 4 or 5 or 6 inches. I'm going to do 4 inches for right now. And let's turn this back on and hit the inspect button to check. That is not an even number. Huh. Let us instead turn that off, and we will inspect from, let's turn you off, from there down to there, and see if we get an even number. Okay, so about 3 inches. It's going diagonally right now, but we did 3 inches is what that looks like. So we change this to 3 inches. One of those things, again, probably better off to come back in here. And, whoops. Again, bad habit of hitting escape. We will add a bracket length to work off of. Just that way we can change it on the fly in the future. Minus bracket length. And then we are good here. So I'm going to come back up, I guess up to the top. We are going to go ahead and make these a rigid joint. Do I want rigid group or just a joint? I'm going to do just a joint for right now. It's going to end up being a rigid group later on. But actually, it may not even do that. I may change this to a slider just so that we can see the exploded view. So that may actually be what ends up happening. But I wanted to do this is the whole entire point here. Turn that off and turn that guy off. Not that guy. That guy. There we go. All right. And now we can come up here. And that guy should now be... Yep. Looks correct. And then we're going to want to... Oh no, we are good because we have wall thickness here. I was going to say we might need to reposition these guys to be in line. That is not the case. So let us go ahead and hop back into the cross beam bracket and proceed on with our plans. So we'll grab that construction plan again because that is on the inside, capture position of the bracket, and we'll just extrude outwards from there. So we project, we want to project that guy. And what else do we want to project? I guess this is fine. So we'll turn those off. Turn the base features off itself, that guy off itself, and the leg bracket. There we go. Just make everything construction lines for right now. That is going to be centered on that guy. And the question is, do we want to call this 1.5 inches or do we want to center it, or how do we want to go about doing this? Do we even want it more than 1.5 inches? I don't know that's necessary to go more than 1.5 inches, so I'm going to go ahead and throw a center line in here, and we will go ahead and, again, there's 1.5 million ways to skin a cat. However you decide is up to you. Oh, actually, I shouldn't use this diagonal, though. This is the wrong way to skin a cat. I should use the other one. Just because the other one... Right? Yeah. The other one is in line with the center line, or should be in line with center line here. It'd be weird if it wasn't. Regardless, let's just... Oh, derp. I was going to say, why is that not... There we go. 1.61. I don't know what I'm doing, obviously. What's... Oh, I've got the wall thickness of... That's why. You got your 6mm wall thickness right here. So, that's going to throw me off right there on the midpoint. So instead, I'm just going to go 1.5, like we were talking about before, and should have just done to begin with. As for the width of this guy, it's kind of arbitrary, I think. Well, I'll just call it 1.5 as well. That way it's just a square. Well, effectively square. Again, it's going to be slightly longer because of the wall thickness in here, but close enough. I don't see a reason why it's going to necessarily matter. So, to object, join. And then we'll hop back up here to leg bracket. And actually, I'm going to drag this guy in here. Oh, no, I can't. Okay. Yeah, I can't. Just triple checking. Alright, we're going to combine that, and cut and keep tools. Okay. Shoot. Right. How do we want to do this guy? Alright, well, what we can do is this. This is what we'll do. We'll come back in here. I guess not in there. Okay, where did we put the sketch for this guy? Sketch for this guy's right there. Nope, not right there. Right there. Yep, right there. We will actually, before this was all just a square, right? So we'll actually delete this and add it later, I think. Is what I'm thinking. And the reason I'm doing it this way, one, obviously we needed to update those formulas that you just saw in order for it to be correct. It was not correct otherwise. Why are you okay? I guess you just were wrong. All right, there we go. And the reason so first off, I just added space in there so the formula was incorrect to begin with. Second off, now by doing it this way, we don't cut that, and we can come back in here, add that back on, and then cut from there. Just thinking if there's anything else I want to do. Yeah, we'll probably back to the roof here. I'll probably hollow that out, or if not hollow it out, then take it straight across here. Let's actually do that right now. I'm gonna go ahead and do that right now. So let's turn that off and distance all, flip it, and hit OK. There we go. So now our only overhangs are right here and here, and this so far can be printed upside down, so it doesn't even matter. So we're actually cool there. The next question is do we actually want to also have, so right now crossbeam bracket is seated up above here. We actually could take this piece of this tongue that's sitting here and extrude it out to the back too. So that right now is getting printed, can be printed face down. We actually probably don't. We probably want to print it upside down, but even at that point, nah, I mean, we don't necessarily want to, unless we clear the whole entire back out, which is, it's not unreasonable. We could just leave a little bit overhang and call it a day. Clear most of the back out and leave a little bit of overhang. That'd be reasonable. So the point being is then we'd have it center aligned here, and we actually wouldn't need to throw that side aligning tab in here onto the top bracket, the leg bracket. Because it would also be center aligning here. So I actually like that idea best. So we're going to go ahead and go with it. We're going to leave this leg bracket how it is right now. It can be printed straight up and down like this, so everything is fine, no overhangs. And then we just got to worry about the crossbeam bracket. So the crossbeam bracket, we are now going to come back here to the tongue, and I'm going to go ahead and project the inside of the inside wall here. There we go. And now we can use that extra projection as our line. Yep. And distance to object there. We'll do that for right now. We could change that. It doesn't have to be the full length here, but you can see now that this bracket is now back aligned against the back of this guy and left and right aligned. So the only question now is whether or not we want to go whole hog and bring this extrusion back on the other side here and cut it again, or we'd move the cut backwards. But point being is then it would be fixed in that way, because right now this leg can go forwards. It's unlikely to go forwards with weight on the table. It's unlikely for this leg to go forwards to spin like this. I'm just gonna grab it to show you. Right now it can technically do one of these deals because there's nothing holding on the backside. It's unlikely, like I said, for it to do that, but we could completely stop that by throwing another piece. Well, not completely, it's one of those things. Again, it's plastic, so it can break, but it would help. What to do, what to do. Sorry, I just got distracted. I just realized that these 8mm magnets that I have in my hand. Let me show you this one. In case you've watched my previous videos, right now, so the 20-hour print that I mentioned at the beginning of the episode, 20-hour print was the bottle capper. I don't know if you recognize this. Let me pull it off the printer. Don't know if that's more familiar for you with the plunger going in here. So I was doing a quick redesign on this, adding this front flange because my brother was using it, and the locking mechanism that I had on this front flange was breaking, which is why I haven't done a video on it. Well, there's a couple of reasons why I haven't done a video on it yet. I wanted to make sure the whole entire thing worked before I did a video on it, so my brother's been testing it. Regardless, the point being is I looked down at these magnets and went, I wonder if those fit inside of here, because one thing I wasn't able to do is put a well, I tried and it didn't work out terribly well, was the problem. But I'm thinking maybe with these 8mm it was, when you put the bottle cap on the bottom there, it just falls straight out, right? Gravity just takes it out. So having a magnet in there would be nice. The problem is that the magnet can't get in the way of the actual pressing situation. It can't stop it from pressing. So that made designing it a bit difficult, and I didn't end up putting it in there. So yeah, we didn't have much to accomplish on this stream anyway, right? You can take a minute to let my ADD kick in here. Do. It's a unpacking video, right? Ooh, gosh darn it, these are... Okay, let's see if it fits. It does fit. So the only question is whether or not that is enough stick for a bottle cap. Whether or not anything... There it goes. So let's see if... it's strong enough to hold the X-Acto knife. I don't have any bottle caps on me. I sent him back home with my brother when he went back to testing it. But that might work right there. And if it doesn't, we might have room for a second one. Let's check. Yeah, check that out. Perfectly lined up on the edge there. See if get the camera to focus. Maybe not. Anyway, that's right on that edge. So that means... No, dog. I think that will work. Well, it's questionable. It's questionable only because the bottle cap, I believe when it's in here, sits roundabout. If you can see these rub marks right here, I think it sits right about there before it gets folded. So whether or not that magnet is strong enough there, when it gets folded, I'm assuming it fills up this entire space, which was making it difficult, which was what made it difficult and why I didn't end up putting it in there. But we'll see whether or not that works. I'll send it home with them and see what the result is. Alright, with that little diversion aside, let's hop back in Fusion and get back to work. So, obviously, like I said, it's a matter of, is it worth the effort? And I don't see any reason why it shouldn't be. So let's go ahead and... Yeah, that is the correct, whatchamacallit. So let's just turn some stuff off so that we can get to it. Turn that body off. Grab that from object. Whoops, not that object, this object. And minus wall thickness. There we go. And then again, we're just going to hop back up here and change the position of this cut. Right, attempt to change this position of this cut. Let's do that. There we go. Now if we hop back over to the leg thing, interesting. Did I extrude that is the question. No, okay, I didn't. Okay. I see what happened here. When I extruded this, I extruded it to the complete backside. Instead, I want to extrude it to the inside right here. And now that should be, yep, lined up correctly. There we go. So yeah, so now that can go straight down like that. Again, it's a question. I didn't want to modify. Sorry. Slow down. Frankly, it'd be easiest just to put dowels in these and combine it with dowels. But the point was being that this was print and play. And if this is going to be print and play, then I don't want to have anybody, you know, drilling holes for dowels, gluing dowels in, etc., etc., etc. So this is my replacement for the dowels, is what it basically comes down to. And again, this is just plastic. What we could do is we could reinforce it. You'd almost want to reinforce it both sides, but we could reinforce it on the inside at least. That wouldn't be terribly obtuse. So let's go ahead and do that, just because. We'll go ahead and toss a whatchamacallit right there. And, whoops, wrong plane. There we go. We will go ahead and throw a supporting beam in here. And the question is, what is our angle? So I'm going to put that there. And then I'm going to check the angle from, whoops, from there. Okay, I was only looking for like a 45, so we're going to go ahead, and that is a 45. It looks like, okay, no, that 45 is off the, off the grid, so we are going to just connect it. And then we can go ahead and toss another line in parallel, and we'll just make that wall thickness. That did not happen the way it was supposed to happen. Okay, let's turn the body off just to see if I'm goofing anything up. Doesn't look like I'm goofing anything up. You're supposed to be parallel, so okay, you are stuck there. You're not trying to go anywhere. Huh, fascinating. Oh, do I have two lines here? Is that what happened? I have two lines here. That is what happened. All right, we back up here. Yeah, you see this extra line right down here? One of those things happens in Fusion every once in a while. Just the click gets misregistered, and then you end up with two lines instead of one. Makes sense. And wall thickness here. Try again. Wall thickness. There we go. And we just extrude that guy out. Bodies. And again, anything below 60 degrees, this is like not 60 degrees. Yeah, should be fine for the printer to print. The other question is, for stability purposes, it may be better for this whole entire assembly to print, technically speaking. Sorry. Get here, flip like this, in this orientation. So let me tilt up towards the top. Tilt up towards the top. There we go. So imagine the bed being down here, okay? Printing in this orientation technically would be stronger because the print layer lines are going perpendicular to everything, so it's going perpendicular to the vertical part here. So the vertical part, vertical leg that goes in here wants to go this direction, right? It wants to torque this direction. The print lines would be going in this direction, so that's perpendicular to that. And then this guy up here, this guy up here doesn't want to do anything in particular, so it doesn't really matter. It's more important for the guys down here. Point being, so what that means is that in theory we wouldn't want this to be so far off this ledge. It could be either ledge, it doesn't necessarily matter which. Let me turn the bracket back on and hop up so that we can see it. So it doesn't necessarily matter which side this is closer to, really, in any practical sense. We would just want it closer to one side. And the reason that we don't have it all the way to one side, which would be the most ideally, we would have this all the way up against this wall, is because then this would slip off, which is what we were trying to avoid in the first place. So the next question would be, can we adjust this geometry so that it's easier for the printer to print, laying down like this. So if the print bit is down here, laying down like this and printing like this, can we make an easier geometry for it to print? And yes, we can. The question is, do we want to? So the one argument why it would not be worth our time, it is kind of worth our time, but the one reason it would not be worth our time is that, let me throw this in here and then make this a 60. So the reason this angle, this is our most severe angle, therefore it's taking up the least amount of space. And actually this doesn't even have to be centered. It could be, you know, like this, let's say, and we would still have the any angle we put in here, even if this is 45. Let me change it to 45 just for argument's sake. That was our most severe. This is our least severe. Well, less severe at any rate. It's not our least severe, but it's less severe. If we're printing this, the layer lines are still going to be jagged, quote unquote. So they're going to not necessarily line up well with the what do you call that? Sorry, brain. With the negative that we impose on this guy, because this guy, well, this guy is technically going to be printed like this. That's what we decided, because we can actually get away with that. Because we can actually get away with that, this guy's going to be printed like this. And therefore, what happens at that point is it's going to, sorry, I'm having more ideas as I'm talking, unfortunately. It's also going to have layer lines in this orientation, which are also going to be jagged. And if you don't understand what I mean by jagged, just because I know I don't have a lot of viewers that are familiar with 3D printing, basically, actually, let me draw this on paper. It'll be faster to draw on paper than in Fusion. All right. The layer lines on a 3D printer basically end up looking like this. So every time it throws down plastic, they're round like this. So if I have a 45-degree angle, okay, I don't actually have a flat 45-degree angle. I have these little round ridges here that make it up. Now, sorry, my hand was in the way. I apologize. So you see how these are round? They generally are not flat. They're, strictly speaking, one of those things, depending on your resolution, may be flat enough. You may never notice. But strictly speaking, they're round like this. And then you start going off on this angle, and you can see how there's little ledges here. They end up being more like steps rather than a straight line. And each of these steps, like I said, is rounded to boot. It's not just a square step, it's rounded. And for that reason, when you try to take the negative here, so this is our other piece right here, and this is the piece that's cutting out of it, this guy's layer lines, you know, are going to have some variation, and it may not line up terribly well. Plus they're round, which means that there's naturally going to be gaps between two rounds. If I draw two half circles right here, right, and then this is my line, you know, this is my box that they're in, you can see how I have gaps in there. So, you know, it's not great. Now, again, it really depends on whether or not it matters how cleanly these faces are meshing. So that is the question. Oh, one thing that because we're doing the beginner friendly version right here, that's only layer lines, right? That's only the vertical layer lines. From the top, if I'm printing something, if I'm printing a square, so say we're looking straight down on this, okay? And this is one layer square, okay? If this is a one layer square, then these corners might be a little bit rounded, but everything is otherwise basically straight. And again, it's only going to be slightly rounded. It's not going to be that big of a deal. Because this is straight down, we don't have bumps like here, 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 here. You know, it doesn't go that direction. So that's why you don't really have a problem printing in this orientation. with layer lines not lining up. So, printer 101 for you guys. And again, we were talking about this just as a reminder because we've gone way off track, because this guy wants to be printed in this orientation so that the layer lines are perpendicular to where it wants to shear. Other orientations, if we printed it, for example, like this, all right, use the cube. Use the force of the cube. Control Z. Sorry. All right, so if we print it like this, okay, and then the vertically, let me turn it on, this guy right here, when this guy flexes back and forth, because it's a leg, it's going to flex, right? This is the leg. I'm not going crazy, right? No, that's a crossbeam. I take it back. That's the crossbeam. These tabs here, though, my point being, the leg, if we print it up like this right here is the leg. There we go. So we're back to the same orientation. This right here is the leg. Same effective orientation. So let me just rotate this. This is what I was talking about right here. So if the layer lines are going in this direction, okay, then that is, it's actually not that bad. I take it back. Let's try to get back there. This is the reason why we don't want to print it this way, though. That's why I dismissed this out of hand. Let's turn sideways here. Remember that we're going to have a bracket up here too. So now we've got an overhang, which is the problem here. So printing this way is actually not that bad because it's perpendicular to the layer lines here. So that's not that big of a deal. But our problem is that we have the overhang right here. Whereas if we print it in this orientation, do that. Nope, not that way. There we go. And spin around so that we can see the front here. So if we print in this orientation, which is why we're trying to get this overhangless right here, this angle here. Now again, the layer lines are going like this, so that's perpendicular to this line, which is what we talked about before. And we don't have overhangs because we're getting rid of the overhangs using this angle. And these two, let me rotate up like this. The one in the front and the one in the back are parallel. They're both going in the same direction. Whereas back the other way, and rotate that way. It's printing in this orientation, and I'll get off center so that we can see it easier. The tabs that would be right here are now perpendicular to the floor. They're parallel to the floor. They're perpendicular to the other stuff. So point being is that this is floating out in space. Probably over-explained that one, but I want to make sure we're all clear on what we're talking about. Now, back to the question at hand, which I kept on coming back to, is, does it really matter? And the honest to gosh truth is, it may not matter. We may go ahead and use this 45, but 45 is really not that big of a deal. And we may say that that 45 is good enough to mesh with the other guy. And more to the point, I'm going to delete this, grab this guy, set this guy to be equal to that guy, just so that I don't have to change both of things, and just make a point right here. Actually, no, I won't. I take it back. We will go ahead and draw the line, and we're only going to do this because that is going to, back to these angles are not going to be perfect, you know, because these things are not going to be perfect. We kind of want to give ourselves every shot in the world at making sure that this fits flush against this guy, and the flat end will give us that little bit. And then it's one of those things, again, we can decide how far we want this. So I will make this 1.25 now. I'm lowering it a little bit because, and the third thing, you'll recall that I cut this guy out in the middle here for center alignment. There's a couple things, right? We could still do that right here, and I'll go ahead and allow it to do that. We're gonna have to fix this, but I wanted to show you, not that. turn that leg bracket off to get this guy. That guy and, oh, whoops. Control Z. This guy right now is a construction line. There we go. Now let's fix this. And turn that guy off so we can actually grab the profile. That guy and that guy. Okay. And that guy. Yep, that is correct. And this guy. Whoops. That guy is missing profile still, even though he was not yellow. Turn off. That guy and that guy. Turn the body back on. And hit join. I'm going to ignore this error right now just so that I can show you what we're looking at. Turn on the leg bracket. And hop up here so that we can look at it. And we did already join. So let's turn this sketch off so it's not in the way. And turn this body off so that you can see it. So you see how this is... when we go to print this, it's now going to be printed like this. Before I said it was going to be printed like this because we had the overhangs. We can print it like this now at this point. The question is back to flat edges. So if I just leave that as is, you can see how we don't have a flat edge up here for it to be sitting on. And therefore we have more meshing issues, I should say. Not just meshing issues, more meshing issues. For that reason, I was thinking, considering doing this. And just taking this straight up like this. Yeah, that should be fine. That should be fine. No, that's not going to be fine, is it? I don't think that's going to be fine. Let me turn this guy back on. Yeah, that's not going to be fine. I take it back. So rather than straight up like this, we'll put a 45 on it. And just move it back a little bit. And by moving it back a little bit, that gives us the flat edge right here, between here and here, to mesh with. So we do that, throw the parallels in, and then make this wall thickness. Wall thickness, okay. And let's see. Do this guy. This is the second guy, right? Yeah, okay. Hit that, hit OK. And come back here and look at this. Oh, that's what I wanted. That's what I need to fix. Derp. Got to come back in here and get rid of these guys. Which is not ideal. Okay, Control Z. It did not occur to me that we were going to have this problem, unfortunately. I did not think hard enough about it. So you see these tabs right here? These tabs right here is what I wanted. I wanted this to come all the way out, though. We should fix this. Bring it straight up here, I guess. Yeah, okay. Maybe do this is what I'm going to claim I was thinking and then just screwed up, right? What if we do that? Let's see what happens. Oh, no. Do this. I don't know. I have it in my head, and for some reason, it's just not getting down onto the model. Okay, this is not going to work because we start the overhang late. Which means that this overhang... Okay. I know how to fix this now. You need to not be here is the problem. And you are that guy? Okay. You need to be in line with that guy. Alright, fine. Do this, throw this construction line in here. Toss that. And do the same thing over here. Yeah, I guess that's that one. Drag you out. Throw you up. Construction line. Toss you in here. And then check out if we have what I was looking for. Okay, so this guy wants to be printed like this. Honestly, it's most happy being printed like this, but he can be printed like this, I guess. It gives me my flat edges that I was hoping for right here. And then if we look at this other part, yeah, that's fine. So let's look at how that's going to be printed just to show ya. Sorry, I'm just thinking now. So I'm looking at the fact that this is solid, and I'm wondering whether or not we need this middle part at this point. I don't think we actually... we don't really. So that middle point was in there. This middle section was in there originally to keep things arranged, aligned left-right. But the fact of the matter is that the tongue does that itself, so I may just get rid of that altogether. Let's delete it. And we will do from instead the inside here and do that. Let's back this guy up. So let's look at how this is going to be printed now. So the printer goes zzz, 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 gets to an overhang, does the overhang just fine, and this is not an overhang, so we're good. And the front side is just a mirror of that. You can pretend like this whole entire front case is not even here. That being said, we do have, printing in this orientation, this overhang here. So the question is, do we want to do something about this overhang here, or do we just leave it? Now, this is something I talked about last time. I said, yeah, you know, you may decide that it's not going to screw everything up enough. You might include some extra offset to make sure it doesn't screw anything up enough. That is something to consider, and a question, because I just changed the orientation. Again, this is the more ideal orientation, so I kind of really want to print this direction. Yeah, we don't really want to print in the other two directions, so we don't want to print, for example, like this. If we print like this, now the layer line is right here at this hinge where this thing wants to break, so that's bad. And then if we flip all the way over, not all the way over, I guess. Yeah, come here, and then I'm just going to rotate like this. If we print in this direction, again, the layer line's with the hinge, plus we have the added problem of this guy being off the ground. That direction, that direction. Okay, so printing in this direction, we also have the layer lines going in this orientation, so that's a problem. And any other directions that I'm missing. Printing like that, bad layer lines. Printing like this is the way that we're printing right now. It's just rotated is all. So no, I'm pretty sure I've covered everything. So that's why this wants to be printed like this. Sorry, we'll rotate like this, use the cube, and offset just so that you can get a reference. Whoops, not that far. Ah, stop it. Stop it. All right, there we go. So printing in this orientation is how we want to do it. So the only question is this overhang right here. Honestly, because I don't have much of a choice with how I'm doing this connection point right here, I think I am going to leave it, and we'll just throw an extra offset in there. As for the extra support, which is these yellow boxes right here, how necessary are they? Let's see. Just because they're going to look a little silly at this point. What's I don't normally use the rib tool, but let's see what it offers us. Rib. Let's turn you off. Oh, I guess I have to do profiles, not faces. Okay. Yeah, again, I don't normally use the rib tool, so Okay, that's how that works. Gotcha. Not really what I want, actually. I was thinking about making a triangle shaped, what you call it? So the way to do that would be with a loft, it looks like. And then we're back to the question of how necessary is it? Nah, I guess we go ahead and do it. Alright, fine. However, we will not be drawing it on this plane. Yeah, we're not going to be drawing on this plane. I think it's best to loft it, so I'm just going to delete all this stuff. Deleted. And then I'm going to go ahead and draw. Whoops. Nope. Don't do that. 0. Draw an outline here. Offsets, etc. Whatever you want to call it. Offsets. Minus wall thickness. Pretty chonky. And the question is, no, I mean, so this is not exactly how I want it because there's no reason to have this right here, this top part. So we will keep that parallel, drag them out. And finish sketch. And then I want to loft it down to here. Just for the heck of it, I'm going to do this really quick just to see what happens. Okay, yeah, it doesn't give me anything coherent. Yeah, just play around with the settings really quick. Just to see. Okay. So this, how do we expect this to work? How does, actually, you know what would be interesting? It's going to be silly to print. It's going to be silly to print, but do we want to try it anyway? Here, just for an idea, okay? Gonna click here, and we'll go 90 degrees. It's silly to print. Technically, the printer can do it. If you look at this, technically the printer can do it. That should be 45 all in there. Huh. I don't hate it, honestly. I honestly do not hate it. I think I'm going to leave it like that for now. The only issue... Actually, no, we should be clearing the front. Yeah, because we're coming off the front of this plane, we will be clearing the leg bracket. So that isn't going to interfere. Yeah, I like it. It gives it a nice little interesting feel to it. We're going to leave it in there. Is it excessive? Yes. It still looks nice. So that is that. Okay, let's hop back up here. And I'm going to toss some colors in here. Plastic. Plastic. Let's grab some normal colors today. White and black. Plastic. Not translucent though. Matte. There we go. Matte white. And where's matte black? There we go. Let's reverse those because the that curve there is easier to see in white. Okay, now we are going to hop in here and duplicate this guy as well. Okay. And then that guy is going to also duplicate this guy and that guy because we're doing components. Okay. And let's hop to the end. And I think everything's still working fine. So let's turn this guy back on. I hit V. I swear I hit V. Oh, I did hit V. This guy needs to be hit V. There we go. So that's where we're at. One thing we haven't done. So we are printing in this orientation, right? Sorry. These guys, the crossbeam brackets, are getting printed in this orientation. And what that means is that when we add this screw up here, we just got to compensate for the for the overhang. Otherwise, the problem we were running into before was we were trying to print in this orientation, and the screw was going into the print bed was our problem. But now that is not going to be a problem. We just gotta, again, compensate for the overhang. Meanwhile, it is 8:22, and I need to be work in 20 minutes to throw that second coat onto the pallet stuff, and my coffee's still not done. Coffee takes 15 minutes, so that's a little bit of a problem. I'm thinking that I'm just not having coffee at this point because I lost track of time. So, anyway, 15 minutes ago I should have made myself coffee. It didn't happen, but we did get this done, and I'm happy about the shape of this thing at this point. Even though we are making some concessions here, and I'm not particularly happy about the overhang on the inside, I think we're doing all right. And also, I did want to actually get that screw done today, but ignore it, okay? It'll get done eventually. So anyway, thank you all for watching. I hope you have a great and wonderful day, afternoon, or evening wherever you're in the world, and I will catch you next time.